Okay, welcome back. All right, so this is the last section for test one. So remember, test one is coming up and it's going to cover homework one, which is all the review topics, and then all of chapter 9. So homework 2 through 5. So it's going to be 1 through 5 homework. So make sure you're reviewing that in My Math Lab. And to be able to go back to your My Math Lab homework, you have to get into My Math Lab and then go to the left navigation bar. There's gradebook in My Math Lab, not the gradebook in Canvas, but the gradebook in My Math Lab. And hit gradebook, and then it'll open up all of your homeworks, and next to it, it'll say review. So you can go back in and kind of review everything. Also review the videos. It's not just the OneNoteLecture notes, but there's also other videos that I posted. So go to tutoring, whatever you need to do, but do not wait till the last minute. This is not a good class to do that. So 9.7 is our last section in chapter 9. I've combined 9.5 and 9.7 together. So it's one homework. They're both homework 5. So that way you don't have as many homeworks to do. And it's the same math concept. It's just we're going to use a new term, and the new term is called marginal. So when you see the term marginal cost, marginal profit, marginal revenue, all that means is derivative. So if you remember in the last lecture, I put a whole series of terms, and I said slope of a tangent line is the derivative. The derivative is a derivative, definition of the derivative, differentiation, and then marginal also means derivative. So all of those terms, it's the exact same math process. So nothing is different as far as how you do it. So let me share my screen and we will get to the last section. So this last section, this is what it looks like in your OneNote. And so again, I'm going to move this over so that I have more room to write. So this is called marginal analysis. And all that means is you are taking a look at the information that you're given and you're finding the derivative of it. In other words, you're finding out how is the profit changing? How is the revenue changing? How is the cost changing? And that's all that means when it comes to marginal. Another term that we're going to introduce is average. So if I look at average cost, well, let me go back. When you're looking at your average test score, so you add up all the tests and then you divide by the number of tests, and that's your average. Well, it's the same thing with cost, average revenue, average profit. You take the entire amount, so the total, and you divide it by the number of products, and that gives you the average cost per item, the average revenue per item, or the average profit per item. And then we add in marginal average cost. So all that means is how is the average cost changing? Is it increasing? Is it decreasing? How is the average revenue changing? And then marginal average profit is how is the average profit changing? So remember, marginal, I'll type it right here. Right here. Marginal equals derivative, which equals change. Okay, so in other words, how is it changing? That's what we're looking at when we're talking about marginal cost, marginal revenue, marginal profit. Okay, so we're going to start with just finding marginal cost. And again, marginal and approximate is going to go together. So we're going to look at the exact cost of something, and then we're going to look at approximate cost of items or profit or revenue. So anytime I use average or marginal, I can connect any of those three terms, cost, revenue, or profit, and it all means the same thing. Okay, so here's your theorem. How do marginals help in the situation? If C of X is the total cost of producing X items, then the marginal cost function approximates the exact cost of producing the X plus 1 item. So in other words, what that means is if I want to know what's the marginal cost or the exact cost of, say, the 800th product. Well, if I find the marginal cost of the 799th product, it gives me an approximation of what the exact cost is going to be. So remember when we were talking about limits and we were talking about how we get close to a value? That's the same idea. If we're looking at a marginal cost, we're looking at how close can I get to the actual cost. That's what I'm looking at. How close can I get to it? So the way that we're going to do this is, if you see the math, right, this is your math terminology. So number one, if you see C of 800, this is the cost to produce the first 800 cars. So in other words, we plug 800 into our cost function and it gives us the total cost of the first 800 cars. If I do C of 799, that is the total cost of producing the first 799 cars. Well, when I find the difference between the two, that gives me the exact cost of the 800th car, because I'm finding the difference between how much did it cost to produce 799 cars, how much did it cost to produce 800 cars, and then when I find the difference between the two, that is the cost of the 800th car, okay? And then, so that's exact. So I'm going to write over here. I'm going to write exact. Okay, so exact is, and I'll use cost of X plus 1 minus the cost of just X. So in other words, if I'm looking for the exact cost of the 50th item, so exact is going to be important, I'm going to do the cost of the 50th minus the cost of the 49th. That's exact. So let me highlight that. Okay, that's the exact cost. If I'm looking at the approximate, gives me marginal, which gives me the derivative of the function of the cost product or cost profit or revenue function. Okay, so approximate, we're going to take, so let's say we want the approximate cost of producing the 50th item. Okay, what we're going to do is we're going to take the derivative of the 49th item. Okay, so we're going to do two different things. When you think of exact, you're going to take the total of what you want minus the total of just underneath it, and then find the difference between the two. Approximate, you're going to find the marginal. And so mathematically, you have to know what you're doing with these two, so that you know when. Oops, that's not what I want. So that you know when to. What is it not picking it up? Hang on. Okay, so approximate is you take one number underneath, because remember you're approaching the 50th. You're not quite there yet. So that's why we have to find the derivative of the 49th, because you're not quite to 50. So you're almost to 50, but not quite. And that's just an approximate cost. Okay, so let's watch mathematically how this works. So when it says, and I'm gonna try to keep the colors the same. When it says marginal, you're going to find the derivative of the function. Okay, so marginal just means derivative. So we're going to come up here and we're going to use your power rule. So remember, I'm going to drop the 2 to the front and multiply. So 2 times 0.04 is 0.08. And then I'm going to subtract 1. So 0.08x minus, and then 110x. So again, remember, there's a 1 here. So we're doing the exact same process. We're dropping that to the front and multiplying. Oops. Get the right color here. So 110. And then when you subtract 1, that goes to x to the 0 power. Well, x, let me do it over here. X to the 0 power equals 1. So that's why when it's just an x, it drops off. Okay, it's the same power rule. It's you drop the 1 to the front and multiply, and then you subtract 1. Well, 1 minus 1 is 0. So x to the 0 power, just so it's clear, x to the 0 power is 1. So 110 times 1 is just 110. Okay, so this is our marginal cost. Okay, and we want the approximate cost. So remember, approximate and marginal is the same. Of the 900th unit. So we're going to take the derivative of 899. Okay, it's always 1 less. Let me highlight this too, so that you have it. And then for this one, it's this. Okay, so 899. So we're going to go 0.08 times 899 minus 110. 0.08 times 899 minus 110. So we get the approximate cost of the 900th unit is a negative 38.08. So what does that mean? What that means is our cost, our approximate cost of producing the 900th unit is going down, right? So that's actually a good thing for a business owner because our costs are dropping. So that means we're in a good place as far as how many we're producing. If our costs were increasing, then we'd have to look at the numbers again and say, okay, how many products should we be making to where our costs are not increasing? So in this case, our costs are decreasing by 3808 with the 900th unit. So that's a good thing. Our costs are decreasing. Now, if it was revenue or profit decreasing, that's not good because revenue profit is what is the money that comes into the business owner. It's what builds the business. Okay, costs are what I have to pay out as a business owner. Okay, and then exact cost, this should have been moved a little bit. The exact cost, so this is 1C, I'll do it over here. The exact cost is going to be the cost of 900 products minus the cost of 899. Now, if you notice, this is actual cost. This is not derivative. So I'm not going to use my derivative function. I'm going to use the actual cost function. So I'm going to find how much does it cost to produce 900, whatever they are, products. So I'm going to go 0.04 times 900 squared minus 110 times 900 plus 100,000. So get that value. So again, watch your order of operations. Do 900 squared times 0.04. And I always write my numbers down because I don't trust my calculator. And then 110 times 900 is 99,000 plus 100,000. And now I have all my numbers. So I'm going to go 32,400 minus 99 plus 100,000. So the cost of producing 900 products is 33,400. the cost of producing 890. And remember, this is total cost. This isn't marginal. This is total cost. So I do the same thing, 0.04 times 899 squared. Oops. And now I'm going to calculate this. So 899 squared times 0.04 is 32,328.04. And then 110 times 899 is 98,890 plus 100,000. So 32,328.04 minus 98,890 plus 100,000. So the cost of 899 products is 33,438. Well, do you notice the difference? So remember, when you're looking for exact, you have to find the difference between the two values. So the total for producing 900 was 33,400. The total cost for 899 is 33,438.04. Well, look at the difference between the two is a negative 38.04. You can see that these two are very close. So remember, this is the cost of the 900, not 800, cost of 900 products minus the cost of 899 products. So this is the exact. This is the approximate, and they should be very, very close. Okay, they should be very, very close. And you can see to find exact, it's a lot more work. Finding the approximate or the marginal, it's way less work, and I'm very, very close to the exact. Okay, so it's a little bit of a shortcut. Okay, so let's try number 2. So revenue of this from the sales of X bottles of Coke, there's my revenue function. I'm gonna block this off so we know it's different. So this is my revenue function. We're gonna determine the marginal revenue function. So again, marginal means derivative. So somewhere in your notes, make sure you write marginal equals derivative. Okay, so marginal equals derivative. So here we go. And again, we're just using our power rule. So the derivative, there's a 1 here. So I'm dropping the 1 to the front and multiplying, so 0.7. And then I'm going to subtract 1, which makes that x to the 0 power. So again, x to the 0 power equals 1. So 0.7 times 1 is just 0.7. And then same thing here, 2 times 0.002 is 2 times 0.001 is 0.002 x, and I'm subtracting 1. So it's just x. So here is my marginal revenue. To find approximate, remember approximate is the same as marginal. So I'm going to go, so I'm not at the 25th, I'm heading towards the 25th. So I'm going to plug in 24. So 0.7 plus 0.002 times 24 is 0.748. Okay, so that means this is approximately, so 70, I can round this up to 75 cents. So I am increasing my revenue by 75 cents on my 25th unit. So that's good. That means my revenue is increasing. Okay, so about 75 cents. So the exact is I'm going to take the revenue at 25 and subtract off the revenue at 24. And it should be close to this number. If it's not close to this number, then I'm doing something wrong. So I plug in my 25. I'll do this over here. So R of 25, my revenue at 25 is 0.7 times 25 plus 0.001 times 25 squared. Notice with the exact, I am using the original function. Exact, you use the original. Approximate, you use the marginal. Okay, so here we go. 25 squared times 0.001. So I'm doing order of operations. That's why I'm working this way. And then 0.7 times 25. So 17.5 plus 0.625. So what it costs me total, or I'm sorry, what the revenue is total when I have 25 products is 18.125. And then my revenue at 24. So revenue at 25 is 18.125. So now I'm going to plug in 24 into the original. So 24 squared times 0.001. And then 0.7 times 24. So my revenue at 24 products is 17.376. And then when I find the difference between the two, it should be very close to my approximate. We'll look at there, 0.749. So that's it, the exact revenue. This is the approximate revenue. Okay, so that's what it costs. Or I'm sorry, that's the revenue on the 25th unit, the exact. This is the approximate revenue for the sale of the 25th unit. Okay, so they go hand in hand. Your answer should always be very, very close. Okay, let's try one for profit now. So determine the profit function. So this takes us back to our review and back to our business algebra. So remember, profit equals the revenue minus the cost. Revenue is all the money that comes in. Cost is what goes out. The difference between the two is your profit. That's what goes either back into your business or into the owner's pocket. Okay, so we have our revenue function. So it's 150 minus 0.02 x squared. There's our revenue. And we're going to subtract off the cost. Oops. Make more room. Now notice I'm putting this in parentheses. The reason why I'm putting this in parentheses is because if I don't have these parentheses here, look what happens. Now I'm only subtracting off 200. I want to subtract off the total cost. Okay, so when I push this negative through everything, I end up with 150 minus 0.02 x squared minus 200 minus 15x plus 0.01 x squared. So make sure you're watching your signs. It's really important that you watch signs because that's where a lot of people mess up. All right, so I'm going to put this in descending order. So I have the profit function. So negative 0.02 x squared plus 0.01 x squared is a negative 0.01 x squared. Okay, so these are done. And then 15x is next. And then 150 minus 200 is a negative 50. There's my profit function. Okay, that's your profit function. So sometimes you have to find the profit. It's revenue minus cost. Okay, all right. So now we're going to find the marginal profit. So marginal profit using the power rule, I drop the 2 to the front and then subtract 1. So negative 0.02x minus, I drop the 1 to the front and multiply. And then when I subtract 1, I get 0. So it's just negative 15. So again, whenever it's x to the first power, it just drops off because it goes to x to the 0 power, which is 1. Okay, so there's my marginal profit. To find the approximate profit, I'm going to take the derivative at the 47.87. Remember, you're not quite to 47.88. You're heading towards that. So that's why we always go one less. So we're going to go negative 0.02 times 47.87 minus 15. Negative 0.02 times 47.87 minus 15. So it's a negative 110.74. So my approximate profit is decreasing by 110 on the 4,788th unit. Okay, so profit's decreasing. That's bad. So now we got to figure out, okay, why is it decreasing? At what point did it start decreasing? What do we need to do to change that? Do we need to produce more products? Do we need to sell less products? I got to sneeze. Okay, exact profit. We're going to take the profit at 47.88, total profit, and we're going to subtract the total profit of 47.87. Okay, that's exact. So come over here and remember we are using the original profit function, not the derivative. We're using the original. So there's your profit function. So 0.01 times 47.88 squared minus 15 times 47.88 minus 50. Oh, and it's negative. So it's a negative 229,249.44. 15 times 47.88. So we have negative 301,119.44. I'm going to stop for a minute. Let me just pause. Okay, so with this next one, I already finished writing it in just to try and save some time. So with exact, we have the exact profit at 4,788. And then we have the exact profit of 47.87. And again, you're using the original function. Okay, exact, you always use the original. So then you find the difference between the two. And the biggest thing here is, don't forget, you have a double negative here. So that means you're adding. So the difference is 110, a negative 110.75. And again, these are very close in value. And they should always be. If they aren't, then there's something wrong. Okay, so that's approximate is the derivative. And then exact, you find the difference between the two values. Okay, so this one is marginal average. So remember, average is you take the whole thing and you divide it by X. So if we're looking for average cost, and this is the notation, so average cost has a bar over it, you take the cost function and you divide it by the number of products. So remember, X always represents the number of products. So our cost function is 55X plus 900 dividing by the number of products. So our average cost is, and you can leave it this way, you can keep it this way, or you can simplify by dividing both the 55X and the 900 by X. So 55x divided by x is just 55. And then 900 divided by x, you can write it this way. So 900 over x, or the average cost could be written like this, 900x to the negative 1. So remember, with a negative exponent, if the exponent is positive on the bottom and I push it to the top, I've flipped it over. So that's where the negative exponent comes in. So either of these works. Okay, so average cost for 100 bikes, we're just going to take the average and plug in 100. Oops, wrong numbers. So 55 plus 900 over 100. So 55 plus 9 is 64. So the average cost per bike is $64 per bike. So you took the total and you divided it by the number of products. To find the marginal average, you take the average cost and then you find the derivative of that. So notice, to find derivative, I had to bring that x on the bottom to the numerator. Otherwise, I can't use the power rule. So 55 is a constant, so that goes to 0. So then I come over here and I use my power rule. I drop my negative 1 to the front and multiply. And then I subtract 1. So it becomes x to the negative 2. So that's my marginal average. So now I'm going to plug 100 into that. Or I can write it this way. Either way works. And you can plug it into your calculator either way. And I get negative 0.09. So what does this mean? This means that your average cost is decreasing by 9 cents when your production level is 100 bikes. Right? So remember, whenever you're doing marginal, that means that's how it's changing. So in this one, the cost is decreasing. The average cost is decreasing. Okay, we're going to stop there. And then I'll finish 9.7 on a second video.